screen, and now you can probably see me as well, and we are going live, and we should be good. Right. Okay, so welcome to this session, everyone, and today we're gonna talk about version control, and we will not only talk about it, but we will also demonstrate this. And let me just hit the recording so that we can have this recorded for our students here on GitHub, not on GitHub, on Google Meet as well. And let me just get the recording started here. All right, so welcome to this demo. In this workshop, we will not only talk, but also show you a little bit what we are talking about as well. So it's all about this this methodology of ours where we talk, show, and then you practice, and then we reflect upon things. That's how we do things here at Craft Academy. And today I have with me Emma. Emma is one of our coaches here at Craft Academy. So say hello to Emma, and Emma, say hello to the people.
Hello.
Hello, Emma.
You're all
Hi, Emma.
doing well, and nice to see some of you.
Fantastic.
Thank you.
So Emma will help me today to prove a few points and show you that the outlined methodology or protocols that we will talk about actually work and bring a lot of effectivity and productivity to the table. So let's get after some theory first, and then we will set up demonstration for you. So Git and GitHub, that's the topic of today. Now, the first thing we need to figure out is, of course, what version control systems actually is. And let me just, oh, there we go. All right, thank you. So what is version control systems, right? Why are we actually bothering with talking about all of this? Well, a version control system is based around very simple yet powerful concept, and that is about tracking changes that happen within certain folders or files over time. Tracking changes that happens within directories or folders or files over time. And of course, there is much more to it, but let me just explain why that might be useful and important in a software development project. The point I want to make, and I want you to internalize this, that apart from you as individuals, with all the knowledge and skills that you carry with you, and your colleagues that also bring a lot of skill sets and experiences and knowledge into a project, the source code itself is the most valuable asset in any software development project that you might be involved in or working on and so on. The source code is really important. So this means that we need to do as much as possible and go to extreme lengths to protect our source code from being corrupted or being handled in a way that will introduce bugs or malicious code or faulty code and so on. So in order to do that, we can just think about a few problems that might occur when you work on software. Apart from banging your head against the desk, which I think we've all had an urge to do at some point in life, there are certain problems that might occur when you work on a piece of software in a collaborative setting, meaning that you are not alone working on it, but rather together with some other people. So there might be a versioning problem. Are you working on the current and latest version of the code? And if you have multiple people working on a project, are they actually working on the same code or not? And also, you need to keep your code secure and hidden, perhaps from the outside world, if you are working on something that is not open sourced. I am a great advocate of open source software, but we also know that a lot of the code that we write is proprietary and not to be spread across the to general public. And I'm going to switch from this slide now because I regret including this animated GIF. It bugs the hell out of me, actually. I hate it. So let's just forget about it. Anyway, so we can store versions. We can have an ability to restore versions if something goes wrong. We can create protocols or workflows that allows for collaboration and collective code ownership. We can track history, and we can bring some security issues into our work on software. So that is basically, in a nutshell, the most important characteristics of working with a version control system, and why that is important to learn. Now, can we work in a smart way? We are rarely alone. I mean, there are, of course, projects that you write on your own, passion projects, experiments, or stuff that you do when you want to learn stuff. But most of the time, as professional developers, we work in a team setting together with others. We work and collaborate in teams, and so when we do that, we need to be able to answer a few questions about our code whenever we approach an area of the code base that we haven't worked on before, or we start our work for the day. There come in multiple scenarios when we want to ask these questions, like when was the file modified, what actually changed, why was it modified, and who is responsible for introducing those changes. And if we could do all that, I think that would be a good thing. And that is exactly where version control comes into play. So we work every day with creating and editing different types of documents, whether they are text files for documentation or source files in whatever language we're working on, whether it's a scripted language or compiled one or what have you. So there are some common things that you do with a file. You create it in the first instance, you work on it, then you save it, you edit it again, you save it again, etc. Right? And that is a repetitive process that we all go through multiple times a day, or often dozens of times even, or if not hundreds of times a day. Now, if we share documents with other people's, like again, they could be text, images, etc. If we don't work with version control systems, but rather follow a more traditional workflow, if there is such a thing, if I'm working on a Word document, for instance, internally at Craft Academy, let's say I'm writing a proposal or make modifications to our curriculum or what have you, and I would like Emma to help me out with this. So then I would have to send the file over to her somehow. It might be over email or through a shared server somewhere, like Google Drive or Dropbox or what have you. And she would go in, change the file, save it again, and then send it back to me somehow, or at least let me know that it has been modified manually. Call me, Slack me, or what have you. And then I would have to download the file, open it up again, and I would probably now end up with two versions of this file on my local computer. The first one that I drafted myself, and then the second one with the changes that Emma introduced. Now, if we work on Google Drive and some other file sharing or information sharing services, you can track changes built into those services, but that is mostly for text documents. Now, if we talk about source code, software, that is a different matter. You shouldn't use Google Drive for that, of course, right? So that's where version control comes in, and the ability of version control systems to track every change, every modification, to files and folders, and that system can track all of that for us and help us to overcome those obstacles. Now, just to be clear, so that there is no misunderstanding, when we talk about Git and GitHub in this context, we have to understand that they are two different things. Git is the version control system itself. It has a history. It was actually created by Linus Torvalds, which is the guy behind Linux. At some other point, I will have a more in-depth workshop on Git with some more advanced commands, and I can fill you into the background story of how Git came about. But you can use Git as a version control system in your individual development if you want, but it comes to its full effect when you do it in a collaborative setting. And the key features of Git is that it's a distributed version control system. It is fast. It allows many people to collaborate on the same project to avoid mistakes and merge conflicts. It is okay to use it while offline. You do not have to be connected to the network in order to use Git itself, because you have a full history tree of all the changes saved locally. And it can also be modified to handle really large projects very efficiently. Now, the Linux kernel is tracked using Git, and that is a massive project with hundreds, or if not thousands of developers working on it. And the flow that the Linux Foundation, I think they are the ones who work on it, have set up, allows for all those developers to work on the same code base without bumping into each other, and definitely without having to bump their heads against the desk because they happen to conflict with another developer at some point. Whereas GitHub is it's a service. It is not a system. It's a cloud-based service, so that allows for collaborative projects and teamwork. It allows you to store your work in a remote on a remote server, in a remote repository, and it helps a lot if you work in collaborative projects or teamwork. Apart from storing, it provides functionality for a lot of other things that are present in our everyday life, like code reviews, forking, and distributing code to other developers, and so on. Repositories on GitHub can be open. They are then called public or private, so that they can be closed sourced if there is a need for that. And of course, key features is that it's an enormous website. Nowadays, it is owned by Microsoft. They bought it, I think it was a year or year and a half ago. So it's scaled really massively. It could be used for simple things, again, as I said, just for online storage, but it could also help you when you work in a collaborative setting to handle large projects efficiently. And so this combo of Git and GitHub is what we use a lot here at Craft Academy, and with success, with good effect. And of course, GitHub is not the only online service that deals with it. There is another one called, for instance, Bitbucket that you can use for this. But I would argue that GitHub is the one that brings most functionality to the table, and the ease of use is superior, I would say. So just to recap that, while Git is about keeping track of changes in code, GitHub is about communication, collaboration, and management of your source code. So Git is the system that you use locally, and GitHub is a service. It's a software as a service, a platform that allows for team communication, collaboration, and management. And if we take a look at other version control systems that might pop up on your horizon when you think about these things, And then you have things like Mercurial, Subversion, you have Performance version, everything, Bazaar, and some others, right? And that is there is a lot of them, and some of them actually bring some more functionality or specific functionality that is really important and useful. I sometimes still use Subversion, although I would also say that Git has become the de facto standard in the industry nowadays, and Git is by far the most widely spread version control system out there. We will at some point later on take a look at some of these version control systems that used to be very popular, but again, they've lost their popularity to Git actually in the last few years at least. All right, so if we take a look at some key concepts of Git, and some of them will actually come into play when we do the demo. There are there's an idea of snapshots in Git, which is the actual recording of all files at any given point in time. And when we say all files, we don't really mean all, but rather those who have went through some sort of a change since the last snapshot. And the commit that we often talk about is the actual thing that you do to create a snapshot. When you do issue the command git commit, then you are actually creating a snapshot of your entire repository and all the files that are under version control. And that brings us to clarify what a repository is. Well, a repository is a collection of all files and folders and the entire history of those files, how they came about, when, and perhaps not why, but definitely by whom, by whose initiative they came about. And when we talk about repositories, we often refer to them as repo. You know, we can talk about local repositories or remote repositories because they can live either on your local machine or on a remote server, which is often the GitHub service. Now, cloning is another thing that comes up often, and that is the act of copying a repository from a remote server to your local machine. There's another concept that we do not mention on this slide, and that is forking, which is basically the act of creating your own version of this repository so that you can use it, and it becomes, you actually copy the entire history to your own account on GitHub, for instance, or if that is the service you are using. And then there is this pushing and pulling concepts that are really, really important, where pulling means that you are downloading the commits and the history that are at any given time not available on your local machine. And pushing is when you push up the changes you have introduced at any given time, and pushing them up to a remote repo, to a remote repository. Branches is another thing, because and that calls for a longer explanation. But at this point, let me just say that branches are commits that are like on a specific version of your repository, and because a repo can have many branches, and the main one is usually called the master branch, or nowadays it's actually referred to as the main branch. I need to update this slide. But if you work on a specific feature and you want to develop something something for your project, you often create a separate branch that diverge from the main branch, and you do your work on that branch locally on your computer or together with a colleague within the team. and then once you guys are done with that particular feature, then you submit that as a proposal to be merged into the main branch of the project, and that goes usually through some sort of a process of code review and some running tests and then trying out if it actually works, and then it's being accepted into the main branch and then deployed to the server if that is the technology you guys are using, meaning that if you are working on a web-based application. So as beginners, there are a few hurdles that and a few things that you need to basically overcome. The lingo is one thing, right? Oh, push this. Did you push to the server? Please pull down, switch branches, do this, do that, right? And that can be a little bit confusing, but it is something that you can get used to. It's an acquired skill, of course, and the only way you can do it is to actually practice this over and over and over again. That is definitely something that you basically need to do many times, because when you do that, it will become a second nature of you. And using your ability to use version control and specifically Git is of course imperative for your ability to work as a professional developer later on. That is something that is set in stone. I usually say that nothing is set in stone, but I would definitely argue that version control systems and your ability to use them, your skills in using them, is a required skill. Right, so let's learn how to collaborate. We are writing code in pairs. We practice a lot of pair programming, and there is not always a possibility for us to sit co-located in the same room. Some of us are in Stockholm, others are in Gothenburg. We have people joining in and listening in all over the world. So there might be a lot of situations when you have to work remotely, right? And that is exactly a very good use case for version control that would definitely allow it to come to its fullest potential. So we have some time to do a demo. Me and Emma will practice this, and I will do very simple stuff. I will exit this presentation for now, and will pull up my terminal. If I just can find my terminal, there it is. Right, and I will make this a little bigger. And I will swiftly navigate to my GitHub account. And while I'm pulling up my browser to this screen, let me just tell you one thing. There are multiple ways of doing what we are doing now. So we have a flow documented for you guys in our course documentation, but and we will try to follow it here on this demo. Let me just check. I have some coloring issues here. Let me just fix that filter. Let me just turn off this chroma key. Right, there we go. I have a green background. I tried to get rid of this. Anyway, but what I will present to you now is just one way of doing things, and so I want you to I don't know, take notes, try to remember this, watch the recording over and over again, and so on, so you can replicate this, but also follow the one that is documented in our course documentation. And if they deviate in some way, it doesn't mean that one is better than the other. It only means that there are different ways to do this, basically. So what I will do now is I will navigate to my repositories, and I have plenty of them because I've been using GitHub for a long time. So I'm going to go to my repositories, and I'm going to create a new repo. So I clicked on the green button, and I will just call this Git demo and hope, no, I'm going to call it Git demo 2021 because they probably already have one that is called Git demo. And this time around, I'm not going to set up any readmes or anything like this, any git ignores, nothing. I will just create a very empty repository for now. So I will just click this, and this is the screen that you will see when you create a new empty repo. And there are some examples of some commands that the good people of GitHub provided for you, and I will actually perhaps use some of them, but I will do it all by myself. So I will ignore this a little bit. But what I will do is to copy this URL, but I will use the HTTPS version, right? So I'm going to click on HTTPS, and I'm going to copy this particular URL, and I'm going to save it for later, right? And what I want to do now is to make this a little bigger again, and I'm going to go over to my Craft Academy folder and demos like this, and I'm going to create a new folder, and just for convenience, sorry, I didn't mean to do this. For convenience, I'm going to call it the same thing that I called my repository, and that was Git demo _ 2021, right? Is that what I call it? Yeah, Git demo 2021, right? And I'm going to cd into this this repository, into this folder, right? And my bash is set up in a way that it tells me where I am on in my file system. You can see that I'm in Craft Academy, demos, and Git demo, right? And what I want to do now inside of that folder is to initialize or initiate a new Git repository. So I will use this command. It's called Git Init. And this command creates a new repo for you locally on your machine. And this is exactly what we are being told. Initialize empty Git repository in, and then the path, and then it points us to a .git folder. And if we now do ls, a regular ls, we don't see anything here. But if we do ls with a flag that we pass in that says A, we can see that there is a new folder here called .git. We will not enter this folder today. We can do it in a few weeks' time because it's quite interesting of what's going on in that folder. But for now, we will just accept that there is a folder inside of this folder, a hidden one. So we don't have to deal more with that. Now, we are supposed to create a folder. So this is our project, right? And this is a project that I want Emma to help me out on. So let's say that we are starting to work on something. I could say something like echo and then my awesome project, and I will output that project, and I will output that to a readme.md. It's going to be a markdown file, right? So if I now open this in my code editor, and I'm going to make this a little bigger. If I open this in my code editor, I can see that there is a readme file, and there is a new header. I can preview this. This is in Markdown, so it will look something like this, my awesome project. And here I would like to add some. In this project, we will, and then I am struck by nothingness. I don't know what to write, right? So let's just save this for now. We will not fill this with any meaningful content. It's not what this demo is about. And if we go back now to to my to my terminal, I can see that there are some new stuff here in my bash prompt, right? So there are some changes that has been introduced to my Git repository. There is new content. So what I can do is to invoke this command, Git Status, and that will show me that I am on a specific branch called master, but I already knew that because I could see that on my prompt. And it also tells me that there are no commits at this point, and but that there exist untracked files. And the file that exists that is not being tracked by Git is the readme.md. So I can add this file to be tracked by Git, and I do it by saying git add readme.md. And if I do git status now, I can see that there are still no commits, but changes to be committed are there because there is actually a file that is being tracked by Git now. So let's clear this up, and I can now do git commit, and I can say pass in 2 flags, and I do this out of habit. I always pass in A and M. A stands for amended files, and M stands for message. So, and I can just add a message, and I do it as a string, and I can say adds readme to project. Adds a readme to project. Okay, so now I can again focus on the GitHub repository that I created, because that's when it comes back into play. And now I'm going to need this this URL, so that points to this particular repository. Because what I want to do now is to connect my local repository to a remote one, to the one that I've created on the service on GitHub. For now, they are not connected in any way, and we can see that because there is a way for us to see what connections have been made, and that is the Git Remote command. And if I hit Git Remote and get an empty output, that means that there is nothing that I am connected to. So I can now say Git Remote Add Origin. Origin is just a best practice name. You can name this whatever, but you usually call it Origin if that is the main branch or the main fork that you are working on. And Git Remote Add Origin, and then pass in this this URL. And before I hit enter, there are 2 versions of this URL. One's with HTTPS and another one with SSH. Now SSH requires you to set up your SSH keys on GitHub, which is something that we will do, and I would encourage everyone to do that. But for now, we're going to use the HTTPS version. So let's do that. And now if I do git remote, we can see that there is an origin added to my on my local host. And I can also hit this command with a flag, and that is V. It stands for verbose, and so that will actually show us what is the URL to that particular remote repository. It is located at github.com Tochman, which is my personal account, and we will use Git Demo 2021, right? So now I can do, again, let's do Git Status, just to check where I am. There is nothing to commit. I already committed my changes in my README file. So now I can push my changes up to the remote server by issuing this git push origin and then master, the master branch. And if I do that, there will be a network communication. And for this action, we need to be connected to the network. But for everything up until now that I did in my terminal, we can be disconnected from the internet. We don't have to be connected. But if we want to communicate with GitHub, of course, we need to push this using the HTTP protocol. So now, if I go back to GitHub, I can refresh this page, and we can see that my awesome project and my README actually exists, right? So at this stage, I would like to ask Emma for help. Hey Emma, can you please help me? I'm stuck on describing this project. So what I could do is I can Slack her or communicate with her and say that, look, could you navigate to my GitHub repository and check out this project, right? So I'm just gonna Slack Emma this thing, if I can just find Emma. Well, I'm gonna Slack it in there we go. So so I just sent that project over to her, and what Emma can do now is to fork this and create her own version of this particular project. So Emma, perhaps you can take it away from now and add some meaningful instructions or content to this README somehow.
Definitely. I'll try my best. I am going to share my screen. There we are. Right, so this is the link that Thomas sent me. So it's basically the same thing. And since we are going to collaborate on this one, I am going to fork his repo, which basically means that I make my own copy out of this repository. And to do so, I will press this little button here that says fork. It gives me an option to where I want to fork it, but I want to fork it to my personal account. And then it says that it should only take a few seconds. So let's hope so. And here we are. And now we can see that this is on my repo. So this is you know on my profile, but this is forked from Thomas's project. So it's basically a copy of Thomas's instance. So what I will do now is to clone this down to my local computer so that I can make some changes to the README. So in this code button, I can simply just press here and it will copy the URL for me, because I need this URL to be able to clone this cloud version down to my computer. So I will close that down. Here we have my terminal. I'm also in my demos folder, and here I can simply do git clone and then paste in this URL. And what this will do for me now is that it will create a new file that folder, sorry, that is named the same thing as the repo. So if I do ls here now, I have quite many things, but we can also see that now I have this Git demo 2021 that I can cd into. And here I already have Git initialized because it's I have cloned this down. And if I do Git Remote -v, just like Thomas did, we can see that I have an origin, and that is my own copy of this project. And the reason why I have that is simply because I cloned the cloud repo, and then this happens automatically for me. But what I need to do now is to, so now if I do code on this one, it will open up the README, and I will have the exact same changes as Thomas had. I'm not really sure what I'm gonna fill this.
You can just add whatever you want. It doesn't really matter.
Right. I will add a little riddle. So, what has to be broken before you can use it? Right. This will be a little riddle project. And now, by doing this, and I can now check, because I have this little green tick, which normally indicates to me that nothing is been that I am in a good state, basically. But if I do Git status now, this will actually tell me that I have modified the README, and that actually changes to a plus now. And I can see that I have something to add if this is what I want to do. And I usually go with, instead of adding the separate file like Thomas did, I usually go with the git add dot, which is basically going to add all of it. So if I would have a lot of files and I had changed all of the files, it's going to add the whole thing. Of course, to be mindful, if you have made a lot of changes that you don't want to commit, that is a bad thing to do. But it's the most convenient thing, I would say. So I will do that. It changes to this little .1. So if we do git status again, it is modified and we can commit this. So I'm basically following the exact same flow like Thomas did when he started the project. I just cloned it down, took my own copy of it, made some changes, and now I can go through the same procedure. So I'll do git commit. We'll also pass in the AM flag, and I will say updated README with a riddle. Cool. And what I can do now is simply to git push origin master to push this up to my own repository. Because this is important to know that I am pushing this to origin, which we could see up here was to my own repo. So if we have a look here now and we swiftly update this, we can see that here we can see that change. What has been broken before what has to be broken before you can use it. But if I go to Thomas and have a look at that one, that is still in the state where it was when he left it, basically. But I have updated my own copy of this project by pushing to me. Do you want me to do anything else, Thomas, or do you want me to send the repo off to you?
You can just push this off, and I will take it from here. I will show them how I can see if there are any forks or existing, stuff. So
Cool.
All right.
I'll stop sharing my screen.
Thank you. So let me just get into no, this one. No, much too sure here. Okay. So Thomas, come on, click on yourself. You need to share the right screen. I'm not sharing the right screen. Where am I? Right. So let's get out of here. Okay. So now you can see my awesome project again, right? Hopefully you can. Can you? Can anybody say if they can see my project?
Yes, we can see.
Good.
Yeah, we
All
can see.
Thank you. Okay, so as Emma said, right, her changes are not visible on my GitHub account yet. This is my README, and it is in this project. We will whatever. But if we focus a little bit on the upper corner, we can see this fork icon, and it says a 1 now. It doesn't said that before. And if I click on this, we can see that there is a hierarchy of forks or versions that is displayed on my screen at the moment. And I can see that out of Tochman Git Demo 2021, Mtallen, or however we want to pronounce this, also forked this. So I can click on this and navigate to Emma's Git repository, and we can see this repo, and it also says right here that this is a fork from my repository. And if we look at her README MD, we can see that the text that she added, this riddle that she added, is actually present there. And there are other differences here that are more important. For instance, we can see here that she has 2 commits done on her version, whereas if you go to mine, there is only one commit. So let's go back to hers and take a look at those commits. So we can click on this, it's a link, and here in this view we can take a look at the commit history on this particular branch, which is the master branch at this point, right? So the first one is the commit that I made with the commit message that I passed in, adds a readme to project, and then we can see the history, updated readme with a riddle. Okay, so now I need all of this to be on my local machine, and then consequently, once that is on my local machine, I need this on my remote because I need to update my project with Emma's changes. So what I can do is to navigate to the main view of our repository and click on this green button that says code and copy this this URL. And again, the choices you are facing now are HTTPS or SSH, which are the ones that I want you to focus on at this point. And then there is this GitHub CLI, which is a different story altogether. We will not cover this today. So I'm going to grab the HTTPS version again for simplicity, just copy it and move over to my terminal. And again, if just a reminder, we can do Git Remote -v to see what sort of remotes we have. Now, I also want to add Emma as a remote to fetch or potentially push to, but that requires a permission from Emma. We don't know if we get that. But what I can do now is to say Git Remote Add, and I can, as I said before, I can give this any name that I want. So I'm just going to say Emma here. And note that I'm using lowercase. It's not because I'm disrespectful to Emma, especially not on the International Women's Day, just because it's simpler for me to give it lowercase names when I type in my terminal. Then I don't have to press down the shift button every time I use this remote. So that is the only reason. I know that all first names should be written with capital in the beginning, of course. So Git Remote Add Emma, and then just pass in this URL. And by the way, Emma, congratulations on the International Women's Day, So now I've said it.
Thank you.
You're welcome. Anyway, Git Remote Add Emma, HTTPS, and the URL. And now we're done. We've added Emma as a remote to our local machine. And if I hit Git Remote -v, I can see that I have two remotes, the origin and Emma. And each remote is divided into two, the fetch and the push, but don't worry about that now. It's perhaps easier to see this without the V flag like this. Okay, so now I want to know what's up with Emma, right? So what has she done? I can do this, and this is something that you can do from time to time when you have different remotes than your own, is to say git fetch Emma like this. And that would give me some metadata about her fork of my repository. Doesn't really matter what all of this means at this point, but the important information here is this that I just highlighted. If you can see that there is a new branch on her repository that is Emma /master, which happens to have the same name as my master, but it's definitely considered a new branch, which means that, and I'm gonna push this up side by side now, just for you to see. I'm gonna clear this up, and I'm gonna go over to my code and close this. We're gonna see the README file on screen when I issue this command: git pull Emma master. And look what happens in my README file. It automatically adds the content that Emma added to this particular file. But if we look at the terminal, you can also see that there is some terminal output from Git. It's always important to read this output. And we can see that we are pulling from this remote repository from this specific branch, and we are updating. And then there are some numbers, or rather hashes, because they are mixed numbers and characters. And then it says fast forward. We don't have to go into what that means exactly, but here we can see that the README file, README MD, has been updated with 2 bytes, I think, of text, or no, 2 lines of text. That's what the 2 pluses actually mean. And so if I now do git log, and I can pass in this 1-line flag, we can see that on my local host, I have 2 commits now. The original one that I created, and also the one that Emma created. Let me make this a little bigger for readability. Update README with a riddle. However, if I go to my own version, somebody else forked this actually, that's interesting. If I go to my own version on GitHub, and if I reload, I still only have 1 commit, because the changes that I pull down are only pulled down to my local computer. I haven't done the step that I need to do to undertake in order to have my remote repository on GitHub to update. And so we're gonna now pull these 2 side by side, because I think there is live reload on this one. And now I can say git push origin master again, which is the origin is my my version on GitHub. And right, no, there is no live reload on this. Oh, well, forget about it. But if I now reload myself, we can now see that change on GitHub, and we can now also see that there are 2 commits, and we have the same version as Emma had on her computer. So we're going to go through this one last time, and I will not share Emma's computer, Emma's screen, or perhaps I do. We'll think about it. But basically, I can now say something like, oh, sorry, that you can't make an omelette it's called like the omelette without breaking a few eggs. So eggs, and then perhaps a smiley or whatever. Right, so that is the answer to her riddle, in my opinion. I don't know. So what I will do now is to do git status. I don't always have to do that, but it's good for demonstration purposes. I modified the README. I can now just do as Emma did, git add, but I can also just do git commit and pass in this AM flag, because A will take all the amended files, and this is a file that is already under version control, and to riddle added to README. And I make a spelling mistake, of course. So like this, boom, and now I do git push again, origin master, and if we go to my repository now, we can see that there are 3 commits now, like this. And if I go to Emma's fork, there, oh, a bit good stuff. And then there are still 2 forks, and probably off camera, Emma, what you can do is just to pull this down and push it up to your own repo, and then we can let me know when that is done, and we can just see that you can update your own repository. Is that okay?
Yep, I'm on it.
You're on it. Okay, and you can also say whether it was right or wrong, and we can wait that extra second to, of course, that will be exciting as hell. and see if if I answered correctly.
Where the heck did it go?
There you go. Where the heck did it go? Well, you never know. Right. So while Emma is preparing this, in this way, we can always make sure that we can have the latest code either on our local machines or in our remote repositories on GitHub. And I do not have to push this up to GitHub. I can push this to Bitbucket or any other service as well. Again, if you think about it, I can have multiple repositories or remotes set up here.
Did you want me to change it or just pull it down and push it up? Because then I'm done.
So pull it down, write if I got it right or wrong, and then push it up, and we will update that screen and see if I actually answered correctly or not. I don't know. So in principle, you know, in a setting, in a pair programming setting where me and Emma can work on, you know, updating the README file like we do here, or work with multiple files and code on a real project, we could push and pull code between the two of us in this particular way. There is another flow where we give each other access to our remote repositories. That is, in my opinion, slightly more correct and secure. But you can also pull in your colleagues. You can, you know, there's nothing that hinders me from having 5, 6, 20 repositories. Well, if you have 20 repositories, then you're probably gonna end up in a shithole anyway, because it will be hard for you to keep track of things. But in principle, you can have multiple repos. All right, so Emma pushed up. So what I will do is to get my README here, and I will now do git pull Emma master, and we will see whether I answered this riddle correctly or if there's another answer to that one. That's correct. That's correct. That's correct. Yes, that's what we're gonna settle for. Good stuff. So we solved the riddle and we demonstrated the Git flow, and that pretty much does it for us today. If you can practice this over back and forward, then you will see that this actually brings a lot of good things to your tool belt. Arun, did you learn anything in this session?
Yep. Hello everyone. So yeah, I learned actually. So I'm gonna try it today. I'm gonna do the practice of it.
Good stuff. Good stuff. Try to do that. That's really awesome if you do. Do you have like a pairing partner or somebody that you can work with
I will send link in Slack if someone will join me. That will be beautiful. But otherwise, I have 2 Git, you know, usernames. So I'll use both of them. I will make their repo and then use another account, and in this way I will do it.
All right. Good stuff. Okay. And Luke, did you learn anything today?
Yeah, I learned plenty. I'll be watching this video a few times to go back through it, make sure I'm doing everything right.
Right. And there is some documentation written on your in your course documentation, you know, in the file. So with more precise instructions and so on.
Yeah.
Awesome. David, did you learn anything today?
Yes. Hi again. Yeah, I did actually. I never used the terminal with the GitHub. So I had the Git extensions and I was using that one before. So it's a program on the Microsoft Windows. So yeah, I will try to use the terminals now. I just opened the information documentation about the terminals, how it works with the GitHub and everything. So I'll try to do it right now.
Good stuff.
Good stuff.
Yeah.
Awesome.
And try to find a partner, so you can Git pong with somebody. Okay.
I can write down my username on the chat. So if someone wants to join me.
And so try to use the Slack channel for that, because then it's persistent. This chat gets lost when we
No, the Slack I meant. Yeah.
Right. Okay.
Yeah, sure.
All right.
Thank you.
And Seva, your input on today's session.
Yeah, it's good. I kind just refresh it once again because I did it already. But repetition is the mother of all learning. So yeah, it's helpful still.
That's great. I love when you say things that I love. I enjoy it a lot. Okay. Emma, any final thoughts? You've been through the bootcamp yourself recently. Was it hard to learn Git and practice Git ponging? Did it bring a lot to the table for you?
It's definitely worth learning it, I would say. Also for your own sakes, when you even if you work on a project yourself, it's nice when you start to experiment a bit too much and f things up a bit too much. Then it's always nice to be able to go back. But definitely it's a good thing to learn, and it is really good to really keep practicing those super silly, easy Git ponging sessions during the prep course, because having the pushing and pulling and committing and adding kind of in your system when starting the bootcamp, it will help you a lot, because then what is being added to the Git ponging is to actually code as well, and then it's nice to only be able to focus on the code and focus on the problem, and kind of the version control and the Git part of it is part of your system already. So I felt a bit silly when updating a README with hello back, hi again, hi, how are you, hello, with someone during the prep course. But it is really good because practicing that then it makes especially the first weeks of the bootcamp a lot easier, because then it's a lot of new information and it's nice to have something under control.
And I always say the more work you put in the prep course, the better you're off in the bootcamp itself, right? Would you agree with that, Emma?
Oh yeah, definitely. Still there is like no lost time, so there is always you can always catch up, but definitely, and especially on those fundamental things, it's really good to keep practicing them, and that's why we're not throwing too much at you, so that you can really hammer in the things that we do give you during the prep course.
All right, awesome, guys. Let's that does it for us now. We will get back to more demos and our daily follow-ups later, but for now we're all set, and I see you in the next demo. Thank you, guys.
All right. Thank you.
Thank you. Cheers.
Bye.
Goodbye.
Thank you.
Bye. So long. Thank you,
See you
Emma,
guys.
for your help. Hej då.
Thank
Det gick bra
you.
det här. Det var-
Jag tror den är lite svår att se när du delar skärmen sådär.
Ja,
För den klipper lite liksom skärmen på
den gör
något
det,
konstigt sätt.
okej.
Ja.
Ja, vi håller på att experimentera med lite grejer, så att det blir lite problematiskt ibland. Men jag ska ta och förfina den här tekniken.
Jag undrar, när du spelar in, när du har den sådär, spelar den in din skärm stort då? Eller är du som en liten ruta?
Jag tror att jag är stor, men jag ska kolla detta faktiskt. Nu på inspelning. Jag tror att den är stor.
Okej. Ja, cool.
Men vi får se. Det är som sagt, vi experimenterar lite grann. För vi försöker få ut det på YouTube automatiskt och på Twitch och du vet överallt. Och
ja. Jag fattar.
All right. Tack så mycket.